Hello, grade 12s. Okay, we're going to continue on with redox here. So this is the second part of that. So we're going to talk about now the electron transfer in redox reactions here. So we looked at the old definition the other day. So we talked about how oxidation was the addition of oxygen, reduction was the loss of oxygen. So now we're going to talk about the modern definition of redox. So we've expanded that definition now to include electron transfer in redox reactions. So today the definition of oxidation and reduction reactions have been extended to include all transfer or shifts of electrons in a chemical reaction. That'll make more sense in a minute here. So the definition, oxidation now is the complete or partial loss of electrons or gain of oxygen, and reduction is the complete or partial gain of electrons or the loss of oxygen. So if we just split our screen here, oxidation, we'd say loss of electrons, so that's LEO. So you can say LEO, loss of electrons or losing electrons is oxidation. Reduction on the other side here is the gain of electrons. And so this one, gaining electrons, is reduction, okay? So Leo and Ger are how you're gonna remember this, because this, you're gonna say, Leo the lion goes grr. Okay, so that is how you are going to remember this. Leo the lion goes grr. Now, there is, weird people who prefer to use oil rig, which is oxidation is losing, reduction is gaining, but who wants an oil rig? Not nearly as cute as our little Leo the lion, right? So you literally are going to use this a lot, and you'll use it as you consider or as you continue your chemistry career, maybe next year if you end up in college or university. Okay, now we're going to just go through here and define an oxidation reduction reaction through an example, and just so you can see what's actually happening here. So if we have magnesium, an atom of magnesium, an atom of sulfur, when these are going to react, so this would be synthesis reaction. If we take these two things and we combine them to make one, it's going to make magnesium sulfide. But before that happens, what you would see, or you wouldn't see it, but magnesium 2+ would be identified and sulfur 2- would be identified, and then we would have our magnesium sulfide, right? So we know that these ions would be created because this is an ionic compound. So what's happening here? So we started out with a certain number of electrons, and then through the midsection here, we know that magnesium lost 2 electrons because it's got a charge of 2+, right? So it's losing electrons. Sulfur has a charge of 2-, so it was able to gain 2 electrons there. So what we can do is we can write what's known as half reactions here. So a half reaction for the oxidation. So we talked about oxidation is Leo. So again, we've got Leo and we've got Ger, right? So losing electrons is the oxidation. So the magnesium had a loss of electrons. We lost 2 electrons. So the magnesium, the half reaction would be magnesium going to Mg2+ plus 2 electrons, because we're showing the reaction we need to balance for charge there. So the magnesium is losing 2 electrons, whereas the sulfur is going to gain 2 electrons here to become sulfur 2-. So one thing I want you to make a note of, what color should I use? Use this one, is this 2 electrons, 2 electrons. So what's on one side for the losing, the same number of electrons has to be gained, okay? So these two reactions are always going to exist with each other. That's why we call them half reactions, and together they're going to make the full reaction here. Now, we have some terminology here. So we have something called the reducing agent. So the reducing agent is the substance that donates the electrons. So if we go back, which one donated the electrons? Magnesium. Magnesium lost the electrons, it gave them away. So that would mean that magnesium is the reducing agent. And we would verbally, you could say magnesium reduces sulfur, so magnesium is the reducing agent. Now, the oxidizing agent is the opposite of this. This is the substance that accepts the electrons, and we know that sulfur gained the electrons, it accepted them. So sulfur is now the oxidizing agent, and we would say sulfur oxidizes magnesium. So sulfur is the oxidizing agent. Now, these are the kind of problems you're going to see here. So what is oxidized, reduced? What is the reducing agent and the oxidizing agent in this single displacement reaction? Now, how we're going to do this, you're going to use your oxidation numbers to show what is reduced and what is oxidized. So oxidation number changes. So an increase in oxidation number means a loss of electrons, okay, and signifies oxidation. So if the number is becoming more positive, we're losing electrons. The opposite of that, a decrease in the oxidation number is going to mean a gain of electrons and is going to signify reduction. So we're going to go ahead and this is why you have to get fast at doing oxidation numbers, because we're going to assign oxidation numbers. Hold on one second. Oh, here we go. We're going to assign our oxidation numbers. That's our first step. And then we're going to look at them and figure out what's happening. So silver by itself, elemental silver is just going to be a 0. Oxygen's -2. The nitrogen's +5. This is going to be +2. Here is 0, -2, +5, +1. Okay, so looking at this, we can now figure out what is oxidized and what is reduced. Now I'm just going to look at the changes here. So silver changed. So silver went from +1 to 0. So it became more negative. So if it becomes more negative, it was reduced, right? Now, I have to look for the other thing that changed, because if one thing is reduced, something else has to be oxidized. And if you look here, copper went from 0 to +2, so it became more positive, which means it lost the negative electrons, right? So this is my Leo here. So I can say then, for my answer, what is oxidized? Copper. What is reduced is going to be in silver. So the silver, I'm going to call it silver plus, okay, because I'm going to put the ionic charge on it there. What is the oxidizing agent? So remember, the oxidizing agent is the thing that is reduced because it oxidizes the other thing. So the oxidizing agent is going to be silver, and the reducing agent is going to be the thing that is oxidized, which is the copper, because the copper reduces the silver. So this is going to be copper here. So that's how you would answer that question. Okay, you would have to answer those 4 species, and you do that by looking at the oxidation numbers. And we'll work through another example here. Okay, so determine again what is oxidized, what is reduced, the reducing agent, and the oxidizing agent. Those are going to be always what I'm asking you for here. Hold on. Okay, so chlorine gas plus hydrogen bromide goes to hydrochloric acid and bromine liquids. So first step, you're going to write your oxidation numbers on top. So 0, -1, +1, -1, +1, 0. So now we're going to use a line and we're going to connect the things that changed. So the chlorine went from 0 to -1, so it became more negative, which means it gained electrons, Gur. Now the bromine went from -1 to 0, so it became more positive. So this is going to be my Leo here. So now when I write down what was oxidized, The thing that was oxidized was your bromine minus. What was reduced was the chlorine gas. Now, which one is the oxidizing agent and the reducing agent? The oxidizing agent is the thing that did the oxidizing. So it's the thing that reduced because the chlorine here oxidized the Br minus, right? So the oxidizing agent is going to be the chlorine 2, and the reducing agent is going to be the bromine minus. Okay, good. We'll work through another example here. Again, you're going to, for first step, identify oxidation numbers. So that's +4, 0, and 0. Okay, so looking at this one, carbon goes from 0 to +4, so that one lost the electrons, lost 4 electrons. And the oxygen went from 0 to -2, so this is my GR here. So again, oops, what is oxidized? What is reduced? Reducing agent, oxidizing agent. So what was oxidized is the copper. That's here. What was reduced is the oxygen, O2. The reducing agent then is the thing that was oxidized. That's going to be the carbon. Did I say copper last time? I think I did. Anyways, carbon. Oxidizing agent is the thing that was reduced. That's going to be your O2. Make sense? Okay, now they get complex, right? So this is a really long one. So again, we're going to go through and we are going to put our oxidation numbers on top. So I would pause the video and see if you can do this on your own. Like try these things on your own first. +1, let's see, +1, this is -3, and then -2, let's see, that's -6, this is +3. Yeah, sorry, I'm just thinking here. -1 +2, -1 +1, and then that's going to be, hold on a second here. Where am I? I just want to check these. Hold on a second. So zinc, yeah, good. And then I have, right, -3 here. That's a 3. And then -2 +4 and 0. Okay, this one's complex. So now we're going to look for the species that changed. So the manganese changed. Manganese went from +4 to +3, so it became more negative. So that is our gaining electrons. And the other thing that changed is our zinc. So we have zinc up here, went from 0 to +2, so it became positive. That's our Leo. Now, if you ever get in a situation where both of these are Leo or both of them are GR, you've made a mistake, okay? So go back and change when one of your oxidation numbers is incorrect. Because one of these things will always be oxidized, one of these things will always be reduced. Okay, so now we can say, okay, what was reduced? What was oxidized? So the thing that was reduced is going to be your manganese, and your manganese is going to be +4. And what was reduced, oh no, sorry, I did that backwards, my apologies. Zinc. And then what was reduced was the manganese. And then your reducing agent then will be your zinc, and your oxidizing agent will be your manganese. Okay, so that's that. You can try now assignment exercise 5. The answer key will be posted, so check your work. Do a bunch of these to just get the hang of them, and then once you have it, it'll be really solid for you. Okay.